Let's dive in. All right, guys. Thanks a lot for joining us today. We're not going to use a tremendous amount of time up, so this will be as efficient as we can make it. The topic today is verified security tests. So this is a relatively new concept that we've been doing here at Prelude, as we have been kind of learning a lot over the years um, about TTPs. And so, kind of explain this difference here in a minute. But my background, real quick, if we haven't met, is I go by Private Ducky online. If you're familiar with that handle, I designed and built the MITRE Caldera framework. Did a lot for MITRE over a few years, and co-founded Prelude with Spencer Thompson in 2020. And since we have been developing a tool called Operator, is where we started, and then we've recently started pushing out quite a big product called Detect. Both of these tools are aimed at the idea of security testing. Operator as a purple team tool designed around the concept of TTPs in semi autonomous types of environments, and Detect in a completely autonomous type of world. What we're going to be talking about specifically today is the topic of security tests. What is a TTP? What is a VST? How do they differ? And then we're going to jump out of the slide deck and go through a little bit of an authoring process and build a custom VST. All right, so TTPs, tactics, techniques, and procedures. These are basically behaviors that you're able to exercise on an endpoint in order to accomplish a goal or evoke a response from the defense. So it's a very squishy term that we've used to describe things like payloads that can run, YAML files that have shell commands in them, applications and agents that we can run on the box that do certain things that are kind of custom execution. We've used all sorts of kind of squishy terms, but it boils down to the ability to run something in order to get some type of output. This has always been a little bit of a sticking point, as we'll get into, in terms of being able to automate the thought process behind a TTP, because it's so squishy, it's hard to create a structure there. Now, a VST you can think of as a production version of a TTP. So these are verified security tests. What makes these different is these tests are designed around safety, and safety is two parts. It doesn't do harm on the endpoint, so no mutation that is harmful, such as a destruction or file removal. And then there's no high system resources that are used, so no spinning up the RAM to full extent or crashing the CPU. You can also reverse the effects, any effects that the test had on the system. So if a file is created, the file can be removed. If a registry key is created, the key can be removed. Another difference is the structure. This is one of the biggest differences, the structure around how a VST exits. So, one of the problems that we've run into with VSTs over the years is the arbitrary output that a TTP can have when run from, say, the shell or within an agent. Whenever you run a command in a TTP, there is text that outputs to the terminal. That text needs to be contextualized, and you need to parse it either automatically or mentally in order to pull out the pieces of information that provide intelligence. Then you utilize those pieces of intelligence in order to unlock your ability to run another TTP, another behavior. That process is because TTPs themselves lack a strict structure. That process becomes very difficult to wrap that additional parsing structure into the common TTP. In VSTs, there's a strict way of handling granularity with what the test actually accomplishes. And we'll see this kind of better in practice, but granularity is a big deal in a VST. The last difference is TTPs kind of take all of these amorphous types of forms like binaries and YAML files and in-memory commands and so forth. VSTs hold the structure that everything will run as a standard binary, making the source language that it's written in completely irrelevant. So the file itself is the container that's encapsulating the security test. The reason for this shift over from TTPs to VSTs when we're talking scale comes down to a few limitations that I've run into with TTPs over the years. And again, so I developed a TTP format for Caldera originally, and I used the YAML format. And then I created another format when I wrote operator, and the formats look very similar, and they do share quite a bit of similarities in the properties that they use in the naming convention and the fact that they're both YAML. But there are a little bit of upgrades in the operator version, and so I'm showing you that version on screen here. We'll show this in full in just a minute as well, but the limitations are around things like cowboy coding, which is if you can run any behavior that does any type of action on an endpoint, there's really nothing that structures you into ensuring safety, ensuring you're not doing anything that's out of bounds. It's really hard to keep safety top of mind. Another limitation is that output. So the standard out, the standard error, we're actually having to parse all of that in order to understand if that TTP was successful. And then the last thing is the separation of a TTP command from the payload itself. So in a lot of cases, what you're doing when you're running a TTP is you are engaging another piece of software. That piece of software could be something that's already installed on the computer in a living on the LAN type of attack, something that is like guaranteed to be there, like curl, for example. Another example is we need to pull something down onto the device in order to use that in order to finish what we're doing inside of the TTP. Now, when you do that inside of an actual TTP, now you have two systems that you have to account for. You have the TTP itself in the file and the structure, and you have a separate binary. Now, what you need is technology that can wrap both of those things together and kind of make sense of each other. And that is a limitation because there is kind of an inherent weight to that structure that you need to either build yourself or get somewhere. In a VST, there are we got it. Here's 8. So we'll go with that. 8 different characteristics that are worth kind of calling out. This may be hard to see at my screen size, so I'll go over these quickly and we'll see these in the actual test code. So the 8 things are number one, endpoint.go. This is a module that we're going to use that has basically like an SDK for test writing. We have build flags that allow us to compile the VST for whatever operating systems that it's compatible for. We can start a test, which allows us to basically run the binary without arguments and kick it off. We can embed malware into the test, which is one of the most interesting aspects of writing tests in the Go language. So you can embed the malware into the actual source code of the test, that payload that I talked about before. So you don't need to download separate software over the network, which can be risky. Instead, it is embedded into the source code. You can still use log statements and standard out, even if you're not going to parse them for output. You can use SDK functions like the quarantine check, which are built-in functions of the SDK. You can execute any technique that you have the creativity to write. And then finally, you can exit the test with one of 4 states, protected, unprotected, an error state, or a not relevant state if the endpoint is not relevant to the test. And so again, 3 benefits to switching to a VST: granularity when it comes to what the output of the test actually accomplished, the ability to run these things safely and scale them up. You can't scale a TTP unless you can guarantee safety. And then finally, the VST, because of the safety and the scale, unlocks the ability to run these things in a truly continuous manner at scale and safe. All right, so we're going to switch out of this view and over to a code editor. All right, so what you're seeing here is Visual Studio, and on the left-hand side, you can see I have a directory called tests. This is a collection of all the tests that I have access to or that I'm using on my local system right now. You can see that they're all in directories that are named after a UUID. Similar to Caldera, similar to Operator, what we're doing in VSTs is using UUID4s in order to name our tests with unique values. So this can be kind of how we reference and identify them. Each one of these directories, as I open them up, I'll pop one open, is going to contain a number of files. A README will exist, which is going to give me kind of a rundown, typical README markdown of what is happening in the test. And then there will be a Go file that will have the actual contents of the test. I'm going to close these down. And what we're going to do is we're going to build one from scratch right now. So to build a test, what we need is the Prelude CLI. This is an open source command line interface that you can access in GitHub in the libraries repository. And maybe Harry can pop that into chat here just to make it an accessible resource. I'm going to go ahead and run Prelude build. So I'm going to hit enter there, and it's going to give me the help menu for what I have available in terms of options. So when I look at this, I can say I'm going to create a test. All right, so let's go ahead and do that. Now when I create a test, I can give it a name. The test that I want to run is going to be an exfiltration. So I'm going to go ahead and type that in, exfiltration over the network. That's the type of test I want to write. I can also attach what's called a unit to the test. The unit is a way to classify the test as a certain category. So you could use MITRE ATT&CK techniques if you want. You could use really an arbitrary string of any kind, however you want to organize. At Prelude, we do have formal units that we leverage. The one I'm going to use in this case is called response, and I'll describe that in a minute. And this goes ahead and it creates the test, and you can see it's applying the default template to it. It gives me a little bit of information on what it just created, and then it drops it on my computer. So it's actually on screen now. So I'm going to go ahead and open it up. And this pops it into my editor. This is the default template of the test. So you can see at the top, we've got a comment block, which is going to give me the ID, the name, the unit, kind of the metadata for what I just created. And then I can get a basic scaffolding of the test itself. Now, one of the things I like to do is I like to switch my imports. We have two versions of the endpoint module. This isn't required. This is something I kind of like to do, is switch mine because I resolve only to the one import at the moment on this machine. What you see here is the test function, which is the function designed to execute the actual test. So this is where I need to fill out the body of a test. I get the cleanup function, which is designed to put in any reverse effects of the test. And then I get a main function, which you can see accepts both the test and clean functions. And what this does is it manages how the test actually runs at runtime. And so let's take that for a quick spin. We're going to do nothing else except build this test as a template and make sure it works. So to do that, I'm going to go into the CLI here. I'm going to use Go, and I'm going to go ahead and build this test with an output file called goose for no other reason than that sounds great. And I'll feed it my Go file. And this is just a run-of-the-mill Go compile command. What this will do is this will compile this source code on screen into a binary that is compatible with what I'm on right now, which is a MacBook M2. You can compile this file for literally any operating system that is common. Now I can see Goose right here, which I'll run, and I can see it ran. So I can see a couple of print statements: starting the test, cleaning up, completed with code 100. Now when I look at the test, I could say, well, none of that is actually in here. There are no print statements. That's because what's occurring is when I call endpoint.start to start the test and endpoint.stop to stop it, I'm invoking the actual endpoint module, which contains basic logic that have safety controls and call them constraints for the test to ensure that it doesn't use too much resources, go too long, that sort of thing. So to see that, this is an open source module. To see that, I'll actually pull up the version on my computer. I think I've got it here. Yep, endpoint.go. And you can follow the path in the import to the GitHub version, of course. I can see what occurs in the start function. And so this allows me to kind of get a really good feel for the SDK, as we'd refer this as, and how this engages with the actual source code of the test itself. So the start function in this case, what it does is it starts a go routine, which is called a background process of sorts, that ensures that this test will not run for more than 10 seconds. If it does, it will stop the test automatically with a code of 102. And so all of these items as an open source utility, SDK, allows you to adjust the test as you want to. Okay, going back to our source code. What we want to do today is we want to fulfill the name of the test, exfiltration over the network. To do that, I'm going to pop open a browser and I'm going to go to a specific operator TTP that does that exact thing. This particular TTP tries to exfiltrate a file from the computer to the open internet over a one-time file share. Now, file.io, there's a number of these available that are popular. Think about it like Pastebin. It's an anonymous location that you can upload files to that will allow you to download through a pre-authorized URL. So no password, no accounts, anything like that. These are common to use in an adversarial sense because websites like these are likely to be allowed through the network and you can exfiltrate. They look benign, and nothing's going to catch them. Could argue that they should be catching one-time file shares because I can't think of a good case for an EDR or an antivirus, some type of endpoint defense, to not be on the lookout for connections that are pushing files from a host to a location like this. And so what we're going to want to do here is we want to test that on my particular machine. So we'll call that our base assumption that this is a file exfiltration over the internet to a one-time file share. I believe my EDR should block this. I do have an EDR installed on my laptop right now. I believe that it should stop this, and I want to see if it will. So what we're going to do is we're going to convert this operator TTP into a VST that we can run from a single file. All right, to do that, we're going to pop back to our Visual Studio instance, so you should be able to see the code again. And we're going to start jotting it down. So starting over here in the test function, the first thing I'm going to want to do, because I don't want to cause harm again, the goal of the VST is to not cause harm. So to not cause harm, I don't want to pull a file that exists already on the computer, because if I do that, what if I choose something that's really sensitive? So what I'm going to do is I'm going to create a new file. So I'm going to utilize the write function that exists in the endpoint module that allows me to write a file to disk. And I'll call it stealdata.txt. And so what this is telling me is I'm going to write a file called stealtext to this location. So at the current root of the test, it's going to have this as a name. And I know this function takes a byte string. We'll just go with hello world. Why not? I'm using Copilot, as you can see, to fill in some of the things, which is helpful when it comes to SDK integrations like this. All right, so this function is going to allow me to write this text into this file, and that's done. Okay, so I created a file. Now, the next thing I can do is I want to actually upload this to file.io. All right, so to do that, I need to go look at the operator command being run for Darwin. Perfect. I'm going to copy that, head back to the code, and I am going to endpoint. I can see it's already filling it in based on my copy, so that's helpful. So let's look at this. So it is saying endpoint. I'm going to call the shell function on endpoint. I want to invoke the bash shell with the C, so to run a command, and my command is going to be to curl the file called stealdata.txt to file.io. Perfect. Now endpoint.shell returns a response and an error. So what we'll do here is we will write that in. The underscore indicates that I'm going to ignore the error just because I don't feel like putting in the error handling now. I probably would I was spending more time. I just care about the response. So I'll go ahead and I will print the response. Perfect. Okay. So now I've got a response that I can run. So let's go ahead and see what happens at this point. I am going to recompile my file into Goose, and I'm going to rerun Goose and see what happens. Okay, perfect. I can see starting test. I get a response that prints out that says a success is true, a 200 response code, which means success, and I get a variety of pieces of information here. So this is great. So what I want to do next is see if I can turn this into a test that can validate whether the EDR is capable of catching that event or not catching that event. So to do that, the first thing I want to do is marshal or unmarshal the response into something that's structured, like JSON would be the typical format, as you can see, would work well for this. So to do that, this is a kind of a go-ism that I need to create a struct. I will call it response. And inside of that, I will create a status of, or an int called status. There's a bunch of other properties in here, as I can see. I only care about the status, which I think you'll see in a minute. So I only care about status. I'll ignore the other stuff. Actually, you know what would be interesting? Probably be interesting to grab the wink. So let's grab that wink too. That's a string. Perfect. Okay, so I created a struct. This will allow me to unmarshal the response into the struct. So to do that, I need to create an instance of the struct. And then I need to unmarshal the response into that new struct. Perfect. I can see that JSON is red. That means I need to import it. So I'll head back up here, import the correct library, make sure that works. Perfect. And what I'm doing here, created the instance. I pass in the reference to the instance and unmarshal that response into this instance. So now R contains all of the data I want. So I can prove that by printing out status, for example. So one thing we could do here is, we'll print out r.link so we can see that. I want to act on status though. I want to say if this worked, meaning a 200 response, that means nobody stopped me from exfiltrating this file. If it didn't work, I can say that this computer is not allowing me to exfiltrate the file. It might not allow me because the defense stopped me. It might not stop me because a firewall stopped me, which is obviously another defense stopping me. It might stop me because the URL itself is 404ing, which we could build a case in for that. But right now, we're just going to take a naive approach, and we'll say if the status was not 200, we are going to assume that we're not allowed to upload it. Actually, we'll do the inverse. We'll say if we are allowed, that means that the defense allowed us to exfiltrate. Got my print statement wrong there. And we'll say uploaded successfully. So if status 200, uploaded successfully. And again, if a file was exfiltrated successfully, we are going to stop the test with a different code. We're going to stop it with 101. That's an exit code, so the same with 100. The exit code here is the granular code that tells us what happened exactly during the test run. And so we're going to say exit with a 101 if we could upload it. Otherwise, we are going to exit the test with a 100. Okay, so what do these mean? What do the 100 mean? What does the 101 mean? So to answer that, I'm going to pop back to a browser, and I'm going to go to a doc page. That's going to give me a table. All right, so these are the granular codes that are supported by Prelude. You can extend this and create or override with your own codes if you have a way to consume and kind of aggregate them. What you're going to see here when we look at the 100 and 101, I can see that 100 is a protected code which means that the test completed normally. That means the computer or the endpoint is protected against the test that ran. The next code down is an unprotected. So this means the test completed normally, but something on the endpoint, we're not prescriptive here, but something should have blocked the test from completing. We would expect the test to get quarantined, the network to block it, the firewall to block it. Sometime during execution, we would have expected to be shut down. So when I pop back to the test and I look at this, I can say, okay, upload successful, 101 unprotected. Else, exit with a 100. Once you call the stop function, the code stops functioning at that point. So that is the same as doing an OS exit in other languages. And again, this is in the endpoint module, so you can kind of see the logic that occurs inside of there. Now, as I look through this, I can say this test doesn't actually require a cleanup function. So I actually have the option of deleting this out, and I can ignore cleanup if I want. If I keep cleanup in, which maybe I will do for the moment, what will happen is cleanup will automatically run as part of the stop routine. And maybe in this case, what I want to do is I want to go endpoint, remove steal data.txt. Yeah, that's probably a good cleanup. I can actually get that off of the system. Okay, so let's give this a run. And so to do that, what I'm going to do is I'm going to build my test again. And I'm going to run it. Okay, so I can see upload successful. I get the file link. I get the cleanup ran, and I get the 101 code printing out to disk. Now, to verify this actually worked, because I'm in development mode, I can actually follow the link, which is also here, as you can see. Paste it into the browser and head over. All right, so now I'm on the file.io side of the fence, and I can see my steal data did in fact get exfiltrated. To make sure it's what I believe, I'll go ahead and download it, take a look, and Hello World is in fact in there. So the exfiltration of that file did go as anticipated, and nothing on my particular computer, my specific defensive policies, looked at that and marked it as malicious. Now, what I can do is I can extend this test, of course. I can add a few more functionalities in. I can run this exfiltration over different file types, maybe different extensions. I could run it maybe 3 file uploads with a second in between. I can try to like provoke the defense to have a response. So I can definitely make this a bigger test than just a single shot upload. But this would be kind of the process of taking any type of command, even something from an operator TTP, a Caldera TTP, a Atomic Red Team TTP, converting that into an equivalent VST, with the goal being, can you take that behavior and really kind of focus it on the defense and try to write something that the defense will be either will respond to or not respond to. And that in effect will allow you to measure what happened during the actual test itself. Now, once you have a test like this, so we've got this test affectionately called Goose on our machine. The question now becomes, how can I run this test outside of this one case? So obviously I can run it on my laptop. I saw it run just fine.
David, you're still in IDE here. Correct?
Yep, still in IDE. Thank you. So the question is, how can I run it? So to answer that, this is where the CLI comes in. So I'm going to do one more command here. So the CLI includes something called the queue. This is going to show me all of the tests that I have running in my environment. So now what we're doing is we're taking the tests that we wrote in VS Code in the completely open source kind of world. All of this can be taken. You can take this test, take it to a computer, take it to a BAS vendor, take it to any command and control and run it as a payload. But this detect queue function now allows us to schedule it if we want within Prelude Detect. And I can see the different test IDs that I currently have scheduled in my own account. And I'm able to see what's called the run code, which is how often they're scheduled. And I can see a tag, which would tell me what types of endpoints should this test run against. Now, what this can do at this point is I can flip over to platform.preludesecurity.com.
Still in CLI here.
Okay, let me do my screen switch to make sure that works. Doesn't seem to hold on to the selection long. All right, you should be able to see a dashboard.
Yep.
Perfect. And once you're over in this dashboard, what you're able to do is you're able to view a running continuous log stream of all the tests that you moved from your development environment, like this one I just wrote called Goose, into your actual security testing environment where you can kind of keep track of all of the things that are green, meaning my defense caught them, or red, meaning the defense did not catch them. This gives me an immediate location or a priority in terms of what I want to look at. Um, and I can head there now. With that, that is how to author, why a VST exists, and how to author a VST. Any questions offhand?